Have you ever looked at a number and it's just so mind-bogglingly huge that it almost doesn't seem real? I'm talking about numbers like the mass of the sun or even bigger stuff. How in the world do scientists and mathematicians deal with these without just getting lost in an ocean of zeros? Well, that's what we're going to unpack today. They have a secret, and we're going to learn it.
Just look at this thing. It's a 10 billion dinara banknote. Can you imagine trying to type that number into a calculator at the grocery store? I mean, you hit one wrong zero and everything's thrown off. It's not just a pain, it's a genuine problem. And you know, in math, we're always looking for a smarter, more elegant way to get things done.
And we go from massive inflation right out into space. Folks at NASA are using numbers like this, the mass of the sun, every single day. The number you're looking at right now has, get this, 30 zeros after the 1989. 30. Trying to multiply or divide with that would be an absolute nightmare. There just has to be a shortcut, right? And of course there is.
And finding that shortcut? Well, that's exactly why we're here. Welcome to Learn with Ease. We are all about simplifying math, giving you those straightforward, super clear explanations that take you from the very basics all the way to feeling like you've completely mastered it. So let's find that better way together.
So what's this big secret for taming these number monsters? It all kicks off with one simple but seriously powerful idea: the index. Now, you might have also heard it called a power or an exponent. This little guy is the mathematical superpower that's going to let us shrink those ginormous numbers into something we can actually handle.
So how does this actually work? Well, an index is basically just a shortcut for multiplying something by itself over and over again. Look at this example, 4 to the power of 3. The big number, the 4, that's our base. It's the number we're actually multiplying. And that little 3 up top, that's the index, and it's just telling us how many times to multiply the base by itself. It really is that simple.
Let's just walk through it together. We start with 4 to the power of 3. So what does that really mean? It means we just expand it out to 4 times another 4. Do the math real quick. 4 times 4 is 16, and 16 times 4 is 64. See, 4 to the power of 3 is just a much neater, more compact way of writing 64.
Okay, now this is where things get really cool. Indices have their own set of rules, but don't think of them like boring grammar rules. No way. Think of them like power-ups in a video game. They're like cheat codes that let you slice through complicated problems without doing all the boring, tedious work.
First up, the multiplication law. Now the key here, the one thing you have to remember, is that the bases have to be the same. If they are, and you're multiplying, you just add the powers together. It's that easy. So x to the power of 5 times x to the power of 2 just becomes x to the power of, well, 5 plus 2, which is x to the power of 7. Think about how much faster that is than writing out x 7 times.
All right, next up is division. And if you understood the last one, you're going to get this one instantly. Since division is pretty much the opposite of multiplication, you do the opposite with the powers. When you divide terms with the same base, you just subtract the powers. So x to the power of 10 divided by x to the power of 4, you guessed it, becomes x to the power of 10 minus 4, which leaves us with x to the power of 6. Simple.
Now for a rule that seems a little weird at first, but it's super important. Any non-zero number raised to the power of 0 is always equal to 1. You might be asking, why? Well, think back to our division rule. What's x squared divided by x squared? Using our rule, it's x to the power of 2 minus 2, which is x to the power of 0. But we also know that anything divided by itself is just 1, so x to the power of 0 has to be 1. It's pretty cool, right? In the example, that means 12a to the 0 just becomes 12 times 1, which is just 12. Okay, so we've got the basics of indices down. Now let's go all the way back to our original problem, those absolutely ridiculous, huge numbers. It's time to unleash the ultimate application of indices, and it's called standard form. Or, if you want to sound like a scientist, you can call it scientific notation.
Standard form has two really simple parts. Let's break it down. The first part, the a, is just a regular number that's always between 1 and 10. The second part is where our index skills come in. It's a power of 10. That index, the n, is the secret key that tells us just how big or how tiny the original number really is. And here is where you see just how amazing standard form is. Look at the mass of the Earth. All of those zeros, gone. They're just replaced by a clean, simple 10 to the power of 24. And get this, it also works for incredibly small things. The mass of a single electron, with all those zeros after the decimal point, is captured perfectly with a negative index, 10 to the power of negative 31. It's so clean, so precise, and there's basically no way to make a mistake. So how do we actually do this? It's a really simple three-step process. First, find your decimal point. If you can't see one, it's hiding at the end of the number. Now just move it until you have a number between 1 and 10. For our example, that gives us 1.2304. Step 2, count how many spots you had to move that decimal. We moved it 6 places to the left, so 6 is our index. And finally, you just write it all out. 1.2304 times 10 to the power of 6. Done.
All right, you've got the theory down pat. Now let's get practical. You're going to be using standard form on your calculator, and trust me, I've got a pro tip here that is going to save you from some really common and really annoying mistakes.
Okay, listen up, because this is a total game changer. Your calculator has a special button just for standard form. It might look like a times 10 to the x button, or maybe just exp. You've got to use that button. If you manually type out times 10 and then the power button, your calculator can get confused, especially with division, and it'll give you the wrong answer. That dedicated button tells your calculator, hey, treat this whole thing as one single number, and it helps you avoid those super frustrating errors.
And just like that, you've unlocked one of the most fundamental tools in all of math and science. I mean, think about it. We started with these scary, intimidating numbers, and now you have the skills to handle them with total confidence. You can read them, you can write them, and you can actually use them. You are literally speaking the language of science now.
Hey, if this explainer helped clear things up for you, could you do us a quick favor? Go ahead and hit that like button, maybe drop a comment, and share it with a friend who might also find it helpful. And of course, make sure you subscribe to Learn with Ease for more content that really makes math make sense.
So we'll leave you with one final thought. We've seen how indices and standard form can describe the mass of the sun, the earth, these massive cosmic objects. But what about your world? Could you use this to describe the number of grains of sand on your favorite beach? Or maybe the number of cells in your own body? The power of powers is absolutely everywhere, and now you know how to find it.